what's matter? So this PowerPoint is going to be about defining matter. You guys don't have to take notes on it right now. Don't worry about it. Just pay attention. You can look at it later. So, essentially, what we want to get out of this is we want to understand that matter has all matter has the property of mass and volume. We should be able to look at something and say if it's matter or not, use the terms appropriately, and appropriately measure the mass and volume, which we'll talk about as a skill as we move on. So we did our activity. So matter has mass and volume. All matter has those two properties, guys. Can you guys just make sure your eyes are up at the board? Okay. What mass is mass is the measures how much matter is present. And it's absolute. So if you have no matter, you have no mass. Right? The more matter you have, the more mass there is. Does that make sense? It's a pretty simple thing, but sometimes that gets confusing. Volume measures how much space the matter occupies. Okay? So if you have no matter, if it's not matter, it can't occupy any space. The units we measure in the SI units, SI stands for Système International. They're the unit people. They're the unit people. I think they're in France, and they just come up with all, or are they in Belgium? I can't remember. But they come up with all the units that are consistent around science in the world, which is also important because we don't want to measure horses in hands anymore. It's important to measure horses in meters or centimeters because that's consistent. Okay? Volume measures how much space they are. You guys are familiar with the units. Liters, centimeters cubed, milliliters. We don't use gallons. Gallons, they're an English unit. And the English don't even use those anymore. They've abandoned them a long time ago. So matter can be a pure substance or a mixture. Right? So groups 1 and 2 were your pure substances. And groups 3 and 4 were our mixtures in our activity that we did today. The difference between a pure substance, element, and a compound is your one type of particle in an element is only made of one type of atom. So all those atoms are the same type of atom. So like, for instance, you had a sample of copper, all those atoms would be copper. If you had 24 karat gold, all of those atoms would be gold. If you had 18 karat gold, that's a mixture now. You're mixing in some silver and copper in there. Compound is when the particle is made up of multiple elements. So like our water, sodium bicarbonate. We have the same types of particle. They're all sodium bicarbonate particles, but that single particle is made up of multiple elements. So, and mixtures are made up of more than one type of particle. The homogeneous mixtures are evenly distributed. Like, for example, air. Air is a great mixture. It's one of my favorite mixtures. It's a mixture of nitrogen and oxygen, essentially. And there's also some argon, carbon dioxide, and water in the atmosphere, and a couple other things. But 78% is nitrogen, 21% is oxygen, and the rest is all the other things. And there's probably some other compounds that we can talk about later. So a homogeneous mixture is they're evenly distributed. So like in this room, you're not going to go to your oxygen part of the room or your nitrogen part of the room. All the particles are mixed fairly evenly. Okay? And a heterogeneous mixture, they're mixed unevenly. You have your separate parts, like your salad dressing. You know, even if you shake the heck out of it, you're going to have your oil part and your vinegar part, your aqueous water part, and your, I don't know, your garlic and your seasonings part. So, we'll talk about that later. Here's the extended matter tree. I really like this diagram. Another name for homogeneous mixtures is a solution. So air is a solution of gas. Like salt water is a solution of salt, sodium chloride, and water. Let's see. Brass is a mixture of copper and zinc. So you can have mixtures in all different phases, homogeneous mixtures. Just depends on how they're mixed. Heterogeneous mixtures, my goodness, you're a heterogeneous mixture. You guys, there's so many different parts of you guys. And soil's a good example. If you have like muddy water, you know, you have your little tiny mud particles and your water particles. Colloids, why are there lines still? Anyway, colloids are a type of heterogeneous mixture like fog or muddy water. Same thing. Like the particles are really tiny, but there are different types of particles, even if you can't really see the individual particles. And interesting thing, if you have a liquid or a gas, that's a heterogeneous mixture. You can have the Tyndall effect. This is a weird SAT topic. Probably I'm not going to test in it. But here's a laser beam. Can you guys see that all right? If you shine it through a homogeneous mixture, nothing will be there. It'll just go through that homogeneous mixture. If it's a liquid or a gas. If it's a solid, it's just going to reflect off of it. But in a heterogeneous liquid or a heterogeneous mixture that has liquid or gas in it, you're going to see the individual tiny particles will reflect that beam. So you'll be able to see the beam through that. That's called the Tyndall effect. Okay? Okay. Whoops. Phases of matter. Pure matter. So if I'm talking about a solid, that's a type of pure matter. So like copper, an example of solid. Solids have a defined shape, defined volume. Liquids have a definite volume, and they take the shape of their container. A gas has no definite shape and expands to fit whatever container it's in. We're going to talk a lot about gas laws. Gas laws are one of my favorite topics. I love them because gases are great. Plasma, not too much on Earth. If you put a grape in a microwave, I'll try to show you guys that soon. Plasma is a type of ionized gas, mainly found in our sun, because sun is really high energy and can ionize a gas. Here's a kind of a definition. And you can, one misconception a lot of people think is that particles in like a solid, they're not moving. Particles in, let's see, how much time do we have? We have a couple minutes. What time is it? Okay. So particles in a solid, they're moving. They're just moving in place. They can like turn around a little bit. I'm a particle, but I'm still moving, right? I'm just moving in place. So if you can imagine a bunch of Mr. Kilgores, that'd be a scary thing for you guys. But if we're all standing in line, moving around, that's what a solid is. Particles are still vibrating, but they're just vibrating in place. Liquids, they're still pretty compact, but they can move around a little bit, right? So I'm like a liquid now. So if there's, liquid is like, if you guys have ever been in the T when you're going to Boston, like, I don't know, after, if you guys are taking the D line from a Red Sox game out to Newton, like by the time you get to, by the time you get through Newton, it clears out a little bit so you can move across the T, but it's still pretty crowded. Whereas the gas is when you get to the Riverside station, and there's like 5 people on the entire train because everybody else has gotten off, and you could probably run and do a cartwheel. That's more like a gas. But a solid is when it's like jam-packed, the Red Sox game just got out, and everybody's huddled in there like this, and it's really hard to move. So that's what a solid's like. Common misconception that gas is not matter. Gas is matter. It has mass and volume. Priestley was a scientist who was, and this is a long time ago. This is in the mid-1700s, mid-late 1700s, when a lot of people had weird views back then. You talk history, like people didn't believe in bacteria or anything. They thought that frogs were born from mud and salamanders were born from fire. So they didn't believe that gases matter, and there's been a lot of scientists. John Dalton was one of them. Priestley, another one. He effectively invented the whoopee cushion by storing gases in pig bladders and would let people sit on them. So he had a great sense of humor. So that's it. That's what we got for today. We'll